Part B, calculator and data booklet allowed. This means we are going into the paper 2 style exam questions. Okay, so the paper 2 of your external exam, for that exam, you're allowed to use the calculator and something called the data booklet. Okay. So for this question 54, we need to state and explain what will happen to the pressure of a given mass of gas when its absolute temperature and volume are both doubled. So for this question, what you need to do is you first have to you have to think about the process into the initial and final section. Okay, so we know that at the initially we had a PV equals nRT, right? And finally we had both its absolute temperature and volume got doubled, right? So it means volume and temperature got doubled. So we can say P times 2V equals nR times 2T. Okay, and from this question we know that their N and R are constant. So we know that the N and R are constant. Okay, so we can rearrange the equations into P over NR equals T over V. Okay, same thing with this. Let's rearrange the equation into P over NR equals 2T over 2V. Okay, then we can set these two parts as equal, which means both T over V is equals to 2T over 2V. And 2T over 2V means we can simplify this and T over V. So we say that even though B and T are doubled, the P stays constant. Okay, so this is 1 mark, 2 mark, 3 marks. Okay, so this question, the total mark is 3 points. And you need to include all this to get the 4 points. Question 55, we have to identify the empirical and molecular formula of the aluminum chloride. Okay, aluminum chloride is Al, we know unknown subscript here, and the chloride unknown subscript. Okay, so we need to find the values that can go into X and Y. So we know that the molecular mass is 267. Okay, so let's first solve the empirical formula. So empirical formula. Okay, we know that Al has the percentage of the 20.3%. Cl has the percentage of 79.7%. To find the empirical formula, we're going to treat the percentage as the gram. Okay, so it becomes 20.3 gram, 79.7 gram, right? And once you have this, you divide these numbers by its molar mass. So for aluminum, we have a 26.98 gram per mole, right? And for the chloride or chlorine, we have 35.43 gram per mole. Okay, so by doing this, we get approximately 1 here, approximately 3. Okay, so we know the empirical formula of the aluminum chloride is Al1 Cl3. To find the molecular formula, okay, we first have to find the mass for the AlCl3, right? Formula mass. We first have to find the formula mass of AlCl3, which is equals to 26.98 gram per mole plus 3 times 35.43 gram per mole. Okay, by doing this, you get 133.5 gram per mole. And once you have this, you divide the divide your molecular mass by its formula mass, right? Then you have 267 divided by 133.5, which is approximately equals to. So your molecular formula is equals to Al2Cl3, right? Because you multiply this to the subscript of your empirical formula. Question 56I. So we have a calcium carbonate which is added to separate solution of the hydrochloric acid and ethanoic acid of the same concentration. We need to state one similarity and one differences in the observation you could make. Okay, so we did experiment on eggshell with the acid during topic 1, right? When you are learning about the topic 1, we did that experiment, or we did it virtually. So when you react a calcium carbonate, which is CaCO3, with acid, okay, what's happening is it's going to bubble, okay? So similarity, it means it's going to create a bubble, so bubbling, and or you can say gas produced or gas given off, but don't say that carbon dioxide gets produced, okay? So you guys often think that when there's gas, you say that, oh, just carbon dioxide, right? But in this case, don't never say carbon dioxide. Just say like it's bubbling or gas given off, or you can even say that you can see the calcium carbonate getting dissolved, okay? That's one similarity, and differences will be, so these differences is more like acid and base topic A section, but you know that the hydrochloric acid is much stronger acid than ethanoic acid, so you can say that the calcium carbonate reacts more vigorously with HCl. Okay. For this question, we know that calcium carbonate is reacting with hydrochloric acid. So this is again is more related to topic 8. Okay, but we know you have to remember that when you react the carbonate solution with the acid, hydrochloric acid in this case, it always produces the salt, water, and carbon dioxide. Okay, that's what you have to remember. And water is H2O liquid, right? And the carbon dioxide is, of course, is gas. And salt that we're going to produce here is the CaCl2. Okay, we know the Ca2 plus and 3O32 minus react together to make the CaCO3. Same thing with the HCl. We know it's HCl combining with the Cl minus, right? So CaCO3 aqueous reacting with HCl aqueous, producing CaCl2 aqueous plus H2O liquid plus CO2 gas. Okay. Once you have this, make sure you balance it out. So we just need to have a 2 in front of HCl. Okay. So for questions like this, you get 1 point for the correct formula and 1 point for the correct balancing and state symbols. Question number III of question number 56. Okay, so now we need to determine the volume of the 1.50 mole per decimal cube hydrochloric acid that would react with exactly 1.25 gram of the calcium carbonate. Okay, so we need to use the balance equation from the previous question. Okay, and we're going to use more ratio from here. Okay, so first let's start with rewriting the equation. Okay, and calcium carbonate is 1.25 gram, and hydrochloric acid, we need to identify its volume, but concentration is given, which is the 1.50 mole per decimeter cube. Okay, so we're going to use the calcium carbonate, because more of the calcium carbonate first, because we can only use the exactly 1.25 gram of the calcium carbonate, which means this is your limiting reactant. Okay, so we start with 1.25 gram of the calcium carbonate, and which convert it to mole using its molar method. Okay, once you have this, you will get the answer of 0.0125 more. Okay, remember you can use calculator for these questions, right? And once you do this, let's identify the mole of the HCl using mole ratio, which means we're going to go from 1 mole to 2 mole, right? So 1 mole of the CaCO3 to 2 mole of HCl. So once you've done this, you can identify the mole of the HCl, which is 0.025 mole of the HCl. Okay, so once you got the mole, you're going to use the concentration of the HCl, which is 1.50 mole per decimeter cube. So I'm going to say the volume of HCl is equals to 0.0250 mole of the HCl times 1 decimeter cube over 1.50 mole, okay, of HCl. Then you get the final answer of 0.0167 decimeter cube. Okay, the significant figure in this question is 3. So you leave your final answer with the 3 sig. Okay, question 1b, which is 4. Question 4 of the question 56. Okay, so now we need to calculate the volume of the carbon dioxide, CO2, which is measured at 273 K and 1.01 times 10 to 5 Pascal, which would be produced when 1.25 gram of calcium carbonate reacts completely with the hydrochloric acid. So now we have to go from the CaCO3 to CO2. Okay, so we're going to use the mole of the CaCO3 from the question 3. So we know that from 1.25 gram of the CaCO3, we produce 0.0125 mole of the CaCO3. Okay, the mole ratio between the CaCO3 and CO2 is 1:1 ratio. So we can say we produce the 0.0125 mole of the CO2. Okay, so once you're done with this, what you need to do is, since it is at standard temperature and standard pressure, we can just use the STP equation to convert the mole to volume to find the mole to volume of the carbon dioxide, right? So STP, we use the number 22.4, right? 22.4 decimeter cube per mole. Okay, so we do the volume of CO2 is equal to 0.0125 mole of CO2 times 22.4 decimeter cube over 1 mole. Then the final answer for this question is 0.28 decimeter cube. Okay. For this question, of course, you can use the equation PV equals nRT, but it's going to take a little more time to solve the question. Question 57. We have an organic compound A contains this 62% by mass of the carbon, 24.1% by mass of nitrogen, the remainder being hydrogen. We need to determine the percentage by mass of the hydrogen and empirical formula of the A. Okay, so to find the percentage by mass of hydrogen, we just subtract the percentage by mass of carbon, the percentage by mass of the nitrogen from 100%. Okay, then we get the percentage by mass of hydrogen, which is equals to 13.9%. Okay, to find the empirical formula, we have a carbon, nitrogen, and hydrogen. Okay, carbon was 62.0%, nitrogen is 24.1%, hydrogen 13.9%, and we treat this as the gram, then we get 62 gram, 24.1 gram, 13.9 gram, right? And we convert this more to these grams, the number of the grams, to the number of the moles by multiplying it with or dividing it with its molar mass. So 12.01, nitrogen 14.01, hydrogen is 1.01. Okay, then you get for the first one you get approximately 5.16, second one you get 1.72, third one you get 13.8. Okay, so once you got this number 5.16, 1.72, 13.8, what you need to do is you have to divide this number by the smallest number. Okay, it's one of the smallest number. So it means, let's rewrite this here. Okay, so 5.16, 1.72, 13.8. So divide everything by 1.72. Okay, then you get approximately here 3, get 1, you get 8, right? So your empirical formula will be C3 and 1H8. 2, we need to define the relative molecular mass. So relative molecular mass means the average mass of the molecular. You can just say the average mass of a molecular. Okay. For the 3, we have to find the relative molecular mass of A. So we have the relative molecular mass of A as the 116, and we need to determine the molecular formula of the A. So we have to use the empirical formula from the question 1, which is C3 and H8, okay? And we're going to find its formula mass first, which is equal to 3 times 12.01 plus 14.01, which is nitrogen, plus 8 times 1.01, okay? Then you get your formula mass, right? Then divide the molecular mass by its formula mass. Then you get 2, okay? So you get 2. Once you get this number, you're going to multiply these 2 with the empirical formula's subscript, which is the C3 and 1H8 times 2. So you multiply it like this, right? Then you get C6 and 2H16. Okay? Question 58. The reaction below represents the reduction of the iron ore to produce iron. So we have a mixture of the 30 kilogram of the Fe2O3 and 5.0 kilogram of carbon, which was heated until no further reaction occurred. Calculate the maximum mass of the iron that can be obtained from these masses of the reactant. So to solve this question, the first step that you need to do is finding the limiting reagent. Okay, so we have a mass of the Fe2O3, which is 30 kilogram, mass of the carbon. So what you want to do is you first want to convert this to mole. Okay, to do that we have to convert the 30 kilogram to gram, which is 30 times 10 to the power of 3 gram of Fe2O3, and convert the 5.0 to gram. Okay, and after that multiply or divide its molar mass. So 1 mole over 159.7 gram and 1 mole of 12.01 gram. Okay, so once you've done this, you will get the 188 more and 460 more. Okay, so we got the number of the moles for each compound, and you can see that if we divide each number by each coefficient, which is 2 and 3, we know right away that this is smaller number than this one, right? So we can say Fe2O3 is your limiting reagent. Okay, so since we have a more of Fe2O3, we can identify the mass of the iron. To do that, we have to convert the mole of Fe2O3 to mole of Fe. After that, we're going to convert that to mass of the Fe. Okay, so we start with the mole of the Fe2O3 because it's limiting reactant or reagent. Okay, and we use mole ratio of the Fe2O3 to Fe, which is 4 mole of Fe over 2 mole of Fe2O3. Okay, after that we use the molar mass of the Fe, which is 55.85 gram over 1 mole. Then we get 21 kilogram. Okay, the suffix of this is 2. Okay, or actually the correct number of the suffix for this question is 1, right? Because it's 30 kilogram. But so you can say 20 kilogram or 21 kilogram. Okay, 2 is still acceptable because the 1 suffix is pretty low. Question 59, we have 0.502 gram of the alkaline metal sulfate, which is dissolved in water, and excess barium chloride solution. BaCl2 is added to precipitate all the sulfate ions as the barium sulfate. Okay, we need to first calculate the mole of the barium sulfate. Okay, so barium sulfate is BaSO4. And we know that this unknown alkali metal sulfate is getting used to make the BaSO4. So what we need to do is we first have to identify, okay, the mole of the molar mass of BaSO4. Okay, so it's 137.34 gram per mole plus sulfur has 32.06 gram per mole. Okay, oxygen is 60. Then you get 233.040 gram per mole as the molar mass of the barium sulfate. Once you have the molar mass of the barium sulfate, you can convert the mass of the barium sulfate to mole. Okay, so we have a 0.672 gram of BaSO4, and we are converting this to mole using its molar mass. Okay, answer is 0.00288, or you can write it write the answer using this scientific notation. 2.88 times 10 to minus 3 mole. So we now have to determine the amount of the alkali metal sulfate present Okay, so you can see that alkaline metal sulfate present is dissolved in water with X, and barium chloride solution is your excess. That means alkaline metal sulfate is your limiting. Okay, so that means whatever you had or whatever you have with the alkaline metal sulfate is all used up to produce the BaSO4. So we can say that they have equal mole ratio. They have like 1-to-1 mole ratio. So we can say the amount of the alkaline metal sulfate has the mole 2.88 times 10 to negative 3 mole. Okay. C. Determine the molar mass of the alkaline metal sulfate and state each unit. So we know the mole of the 2.88 times 10, the mole of the alkaline metal sulfate is 2.88 times 10 to negative 3 mole, and we need to find the molar mass. Molar mass unit is gram per mole. So we can say using the mass, you can say mass divided by the mole is equal to molar mass. So mass of the alkaline metal sulfate is 0.502 gram, and we divide that by its mole, which is 2.88 times 10 to negative 3. Okay, then the answer is 174.31, but significant figure in this case is 3, so we have to write it as 174 gram per mole. Question D, we need to deduce the identity of the alkaline metal showing, and we need to show our work. Okay, so we know that the molar mass is 174 gram per mole. Okay, and alkaline metal sulfate is like unknown metal with the sulfate SO4. Okay, so we can say the unknown metals like molar atomic mass, okay, plus sulfur, its mass is 32, and plus 4 times oxygen. Okay, and also when you do working backward, you need to remember to check the subscript. Okay, so alkaline metal means it is a group 1, so means it has the positive 1 charge. SO4 is the anion that has the minus 2 charge, means the metal will have a subscript of 2, right? So we have to put 2 here. So 2m plus 32 plus 4 times 16 will equal to 174. Now we have to do little math. Okay, then it's 174 minus 32 plus 4 times 16. Then we divide each by 2, right? Then we get the mass equal to 39. So we can say our unknown alkaline metal is the potassium. Okay, now we have to write an equation for the precipitation reaction including the stick symbol. So we know that the alkaline metal is K, potassium, so it's K2SO4 solution is aqueous, okay, reacting with the barium chloride solution, okay, and producing a barium sulfate, BaSO4, and this is precipitate, so it's solid, and producing KCl solution. Okay, so now we need to balance it out, so we get 2 over here. Question 60, we have a 0.600 mole of the aluminum hydroxide, and it's mixed with the 0.600 mole of the sulfuric acid, and we first need to determine the remaining reactant, right? So we take AlOH3 and H2SO4. Okay, so 0.600 mole, both has same mole number of the moles, right? So take the coefficient of each compound and divide its mole by it. Okay, then get 0.300, 0.200, Okay, that means H2SO4 is our limiting reactant. Okay. Question B, we have to calculate the mass of the Al2SO4 produced. So we're going to start with the limiting reactant, which is H2SO4. So we go 0.600 mole of the H2SO4, and we are converting this to the Al2SO4 okay, and H2SO4 has a coefficient of 3, so we place the 3 here. Okay, then we get the answer of 0.200 mole of the Al2SO4. Okay, so we can be question C. So now we need to determine the amount of the excess reactant that remains. So we're going to figure it out how much we use to produce the how much of the AlOH3 we use to produce the Al2SO4. So we're going to start with 0.600 mole of the H2SO4, and we're going to convert this mole of H2SO4 to mole of the AlOH3 to identify the amount that we use with the H2SO4. Okay, then we get 0.200, then we get 0.400 mole of AlOH3. So we know that we use this much of the AlOH3. Then we just subtract this number from the total to get the remain. Remain is 0.600 minus 6.400. That is 0.200 mole of AlOH3 remains.